Hi everybody, welcome to another video in trigonometry, section 3.2, arc length. Actually in this section we cover two important things, arc length, length of an arc, and the area of the sector. This is very short section. So on the previous section we defined that in the radian measure, so it's extremely important. It has to be, the angle has to be in the radian measure. In that case, that measure is equal to the length of an arc. So the arc length S and the radius R, or the arc length is equal to S equal to R times the arc length. So very straightforward. The only thing we need to worry about, once again, the angle has to be in radian. In that case, the length equal to the radius times the angle. Straightforward, right? And that is exactly that. So first, look at the examples. A circle has the radius of 18. So the radius is 18. Find the length of an arc intercept by the central angle. So the length of an arc, we don't know. And the central angle is 210 degrees. Right. So what is the most important thing on this problem? The angle must be in radian, right? So if we want to convert to radian, we did this in previous section. If we don't want degree, put degree at the bottom. If we want radian, put pi on the top. Degree cancel out. 210 divided by 180. Uh, 7/6. The pi is still there, right? So that is 7 pi/6. That is the angle in radian. And finally, the arc length is equal to the radius times the angle measured in radian. So we just do that. So the radius 18 inches. Worry about that in a minute, the unit. Or here we just put the unit if we want to. 18 inches. The angle 7 pi/6 radian. But radian is special unit as mentioned before. In previous section, we can just take it out or put it in whenever we want to. So, and then the unit when we do all of this, it's going to be inches. And I just combine all the math. 18 times 7. 126/6 pi inches. But if we just want to estimate, we just take 126 pi divided by 6. By the way, we can reduce by 126 divided by 6. That should be 42. 42 pi inches. 18 and 6 cancel out 3 times. 18 and 6 cancel out, that 3 times 7 will be 21. Sorry. So 21 pi. If we want to get approximation, 21 times pi, 21 times 3.14 or so, or just 21 pi second, and that button. So about 65.97 inches. So straightforward, right? Make sure that the angle is in degree, and that's all we need. Right, next, use 3960 miles as the radius of the Earth. So radius is 39 and 60 mile radius of the Earth. Let's put inches here too. And what else we have? 440 miles due north of border. So what do we have here? So try to draw a little circle. I'm not going to draw the whole circle, just draw the northern hemisphere, which is a quarter of a circle. Right. So let's say center of the Earth is here, and the radius of the Earth 3960 mile. So if we just do the cross section, because Miles City and Boulder, that's directly north of each other. So what we know is Miles City and Boulder I got the geometry wrong. The Boulder is north of. Right. Sorry about that. I have to go quickly go to Google Map and check. This is a typo. When I type it is Miles City, is not in Nevada. It is Montana. So in which case, of course, it is due north of Colorado. So Boulder is on the south and Miles City is on the north. Right. I'll change that when I post the note online. Right. The distance between them, though, 440 miles. So in that case, they said find the difference in altitude. So pretty much they asked what would be the angle, the central angle here. It works because it is directly north to it. If it is off a little back and forth, then it will not work. So that's why I have to go back and check with the Google Map. And actually, so Miles City is on north Boulder, directly north. So that's why we can find it. If it is a little off, the calculation will be extremely difficult because it is directly north. So we can cut the Earth, cut the cross section, and this is what we have. So basically, we have the arc length is 440 miles. The question is, what is the difference in latitude? So. So, straightforward, right? S equal to R times theta, or theta, the arc length, theta is the angle, is equal to S divided by R. So the S is 440 mile, the radius 3960 mile. 440 divided by 3960. So that is about 1/9. And I ask you, what is the unit here? This is the measure of angle. And in angle, we learn up to this point degree or radian. Certainly it's not degree here, right? Because if it is degree, we should have degree. The special unit of radian, we can just put it back in when we need to. So there. So it is 1/9 radian. But in terms of degree, what is that? So it is 1/9. We don't even need the radian. If we want degree, multiply by something that has degree on top and divide by pi. So we have 180 divided by 9 divided by pi, so 180 divided by 9 pi. So that's about 6.3 degrees. 6.37 degree. So does that make sense? Remember, this is 1/9 of a radian. A radian we have earlier from the previous section is about 57.3 degrees. So 1/9 of that. That's reasonable, right? If we multiply by 9, yeah, so that's like 1 radian. Right, so straightforward. Should make sure that all the calculation in here has to be in radian, because the formula only works if it is in the radian measure. Alright, so that's the first part of the section, the arc length. Arc length is equal to the radius times the central angle in radian. Right, next part of the section is the area of the sector. The area of a sector, by the way, will form by two radius. Cut a circle, so this is a sector. A sector formed by two sides of the central angle. Of course, the central angle, the vertex at the radius and the vertex at the center. So those are two radii. So that is the sector, pretty much. The formula for the area of the sector is 1/2 r squared theta. Okay. I can actually kind of prove it. It's not perfect proof, but I think that we do. So if we have the central angle theta, if that angle is theta, the arc length here is equal to what? R times theta, right? The radius, of course, is here and here. Now think about this. What if we draw it is like this, with S here, and the radius can be anywhere, can be here, here, or here. And that looks like a triangle, right? And the area, if that is 1/2 base times height. Right? If you turn the sector around and it looks like a triangle, and so it's like that. Now, 1/2 S, the arc length is r theta, and times r. R times r, make it 1/2 r squared theta, and that's exactly what we have. Right, so the area of the sector is equal to 1/2 the radius square times the radius square times the angle. Make sure, as always, it has to be in radian measure. So area of the sector. Right, next, just go to the example. How many square inches of pizza has a person in if he eats a sector of the pizza 18 inches in diameter whose edge form 30 degrees. So let's just write everything we have. First, the diameter is 18 degrees. 18 inches. The formula doesn't have diameter, right? It only has radius. So make sure this question, 18 in diameter, equivalent to the radius is half of that. Half of that would be 9 inches. So 18 inches divided by 2. The radius is 9 inches. The edge form an angle, so that's 30 degrees. And the question is, how many square inches, meaning asking for the area. So pretty straightforward, right? Right. Just one thing we always have to do. Make sure that it is in radian mode. Meaning that if we don't want degree, put it at the bottom. Pi in the top, degree cancel out. and 30 divided by 180. By now, I hope you recognize that is pi over 6. So pi over 6 radian. And after that, area is 1/2 radius square times the angle. So 1/2 the radius square 9 inches square, that gives us inches, and then pi over 6 radian. So the radian is the unit where we cancel by itself. With the unit will be inches square. And so we have the numbers 1/2. I'm just going to give 0.2, 0.5 times 9 square times pi divided by 6. So about 21.2 inches square. Simple enough, right? Yeah. Just make sure that 9 square is 81 times that, and then times pi over 6. So exactly what we have in the calculator over there. Right. The unit inches square. That's why we end up with inches square. Simple enough. Right. Another example. A goat is tethered to the corner of a fence by 10-foot rope. Assume that the goat can move freely to the full extent of the rope. Find the area of land that the goat can graze. So pretty much we have a corner, and the corner of the fence, we assume that it is perfectly 90 degrees because it did not specify, but conventional wisdom when we talk about the corner of a fence, that should be 90 degrees. Although I should specify that into the prompt. To the corner of 90 degrees, right? Just like that. And the goat can tether to the full extent of, can go freely in the full extent of the rope. So that is 10-foot rope. And find the area. So pretty much we find the area of this sector, which is a quarter of a disc or circle. Right. So the radius in this case 10 feet. The angle 90 degrees. Convert to radian right away. So that gives us cancel pi over 2. And the question asks us for what is the area. Right. So the area is equal to 1/2 r square theta. So if we just have 1/2, r is 10, feet, and theta pi over 2 radian, or just pi over 2. Right. So 1/2 times 10 square, that's 100 divided by 2. So if we do that by hand, 10 square is 100 times pi on the top, and then divide by 4 at the bottom, and the unit is square feet. That gives us 25 pi square feet, which is equivalent to 78.53 square feet. Right. So that's good. That's good. Right. However, the formula is nice and all, but you can even do that without the formula. Just do ratio and proportional. We still need to know the area of a disk or area of a circle. So this problem, in the last problem, we write that 1 revolution or 360 degree. If we have 360 degree, we have the full circle, right? The full circle of radius 10. So the radius is equal to pi r squared, the area of a circle. The radius is 10, so that will be 100 pi. One full circle is 100 pi. What if we just have 90 degree? What will be equivalent area? So just set up the ratio. 360 divided by 90 equal to 10 pi, 100 pi, sorry. 100 pi divided by x. And cross multiply, by the way, this simplified to 4 over 1. Cross multiply, we have 4x equal to 100 pi. And so on for x, we have 100 pi divided by 4. So my point is, we just, in general, we just write out 360 degree, the whole circle, the area will be that. Now, equivalent to 90 degree, what will be the area? We just set up the ratio of proportion. In that case, we don't even need the formulas. Right, try another one. Arc length. Let's say this one, for example. The radius is 18, and an arc, the angle is 210 degrees. The arc length is what? We can forget about the formula. We just said if we have 360 degrees, that means the whole circle. The whole circle, though, the arc length is equal to the circumference, which is 2 pi r. So we have 360 degrees is equivalent to 2 pi r. 2 pi r is 18. So we have 36 pi. Now if the arc length is 36 pi, because the unit is inches, then what if we only have 210 degrees? What would be the equivalent arc length of that? Right. So we just set up the ratio proportion. If we know the circumference of a circle and then the area of a disk, area of a circle, right? We just set up the ratio to 360 divided by 210 is equal to 36 pi divided by x. Cross multiply 360x equal to 36 pi times 210. And so 36 times 210. 750 pi, and then divide by 360, so 756, 7560 x, pi, divide by 360, so end up with 65.97. So we just set up the ratio and proportional problem for one complete circle or the whole disk 360 degrees. We have that much. What if we just have an angle in degrees? What equivalent to that? So doing like this, we don't need to convert to radian. But if we convert everything to radian, the formula is there and there. Straightforward, right? The ratio proportion, when we do that, we don't need to convert because we work originally with 360 degrees. Right. Of course, if you forgot the formula, that's what to do. But if we convert everything to radian, just use that for the area of the sector and that for the arc length. That's straightforward, and there should not be any problem about this. Right. So with that, I stop section 3.2 here. As always, thank you for watching, and see you in another video in trigonometry.